Let me solve this problem together with you. First, I'll imagine this is a clock. This is 12. This is 3. This is 6. This is 9. This is 6. 11:30. This is 10. 11. 11:30. This our hand shows 11:30 and 5:30. This is 4, 5, and this is 5:30. Okay. How many feet tip when it moves from 11:30 to 5:30? This 5:30. This 11:30. Let me solve by myself. Like if you remember, we did in this AM morning, like we did in fourth grade, how we found elapsing time. So step number 1, delta time, elapsing time. 5:30 p.m. is the same like 5 plus 12, 17:30, right? Yes or no, military time. It's the same like 17:30. You know, in military, they added 12 hours in order to avoid discrepancy. Evening, some of you have clocks, Italy clocks, wherever they have 17:30 like this. Understand, 5:30 is the same like 17:30, plus 12 hours, right? So 17:30 minus 11:30. There are how many hours pass? 6 hours. Between this and this, 6 hours. You can go by this one, but this is fast. Okay, now step number 2. Circumference equals 2 pi r. Remember, students, the formula for circumference. And since our radius is 24 inches, it equals 2 pi times 24, which is 48 pi. This is my circumference. I just use formula we use in 5th grade. 2 pi r. Understand this step. So if I just plug in radius to this formula, nothing else. Makar, Emma, Daniel. Now look at this. And this entire 48 pi, what is length? Is length of this tip it goes like this. Is 360 degrees. Or let me use not 360 degrees. I use hours, right? This is 12 hours. 12 hours. This is in hours. And 6 hours, I have no idea. It's, imagine this is a pie, pizza. The bigger this angle, the bigger slice and bigger this length of arc. So step number 3, cross. X times 12 equals 48 pi times 6. Divide by 12. Divide by 12. Cancel, cancel. 12 goes into 48 4 times. 4 times 6, 24 pi. Okay. If you have any question, ask me. Who need explanation? Put your hands down if you don't have questions. Who need explanation what is pi? Pi. To remind you. Who would like to need what is pi? You can check, you can, if you have measurement tape, you can get pi at your kitchen today, everybody. Go to your kitchen, right? Take a measurement tape, like any measurement tape. You don't have tape, can some thread and ruler. After that, take any circular object, let's say plate. Okay, and put on this plate some starting point, like I did, red one. After that, put over there beginning of this measurement tape. Okay, and you measure how long is in millimeters. Okay, measure this distance. After that, measure diameter from here to here, diameter. And to be specific, you can use what? Few plates. And pi is a ratio. Pi is circumference divided by diameter. Let's say if I measure, this is, pretend for simplicity. Okay, 31.4, and this is 10. When you divide, you get about 3.14. Ancient Greek who developed, they were surprised, very surprised, because why? They have different objects, wherever you take, I don't know, what this one. Any, huge, small, when you divide circumference or perimeter of this by the area, you get about the same number. And this number pi, it's a rational number, never ending, 3.14. Or very roughly, sometimes on the test they use pi equals 22/7. Even though this is not precise, but for estimation. This is pi. But pi is a rational number, never ending. Pi is just a ratio, circumference to diameter, easy. And everybody, if you measure, the more precise you measure, the closer to 3.14 you get. And roughly this distance is much longer, much longer. If I have this about these criminals, just a second, Olga. While I do this, I give you one of my favorite examples from American movie where two criminals, they discuss pi. Okay, when I see this, raise your hand. It takes 2 minutes, about 3 minutes. You have fun. Very famous actors, and I never remember names, but you'll have fun if manager finds. Okay, this is pi. Who understand this problem? So again, this is circumference length. And this is 12 hours. Sometimes you use 360 degrees. And this one, elapsing time is 6 hours. Make proportion, because the bigger circumference, the bigger arc, the bigger this, the bigger arc. The smaller this, between this, the smaller arc. Proportion. Okay, good, good, good. So this I solve for you another problem when you have it homework with different numbers, okay? Let's move to problem number 3. Any questions before we move? Okay. No question? Good. Let me move to another one. Problem number 3. File manager looking for. Another problem is problem number 5. Actually, this is two-step problem. I just illustrated this, but this is two-step problem. Problem number 5. If the radius, write it down, of a circle is increased by blank, the circumference is increased by no, let me give you a number. In just a second. Also these numbers. Let me make some. I made up by 6. Okay. So let's make. I solve it myself. Okay, since we're out of time. Then you have a circle. They don't specify the radius. We don't know this radius. Let's say x. And after that, you make it bigger. You make it bigger. So this is 6. A new radius becomes what? If I make circumference here, not nice, but a new circumference becomes x plus 6. Okay? So this R1 and this R2. So since you know circumference equals 2 pi r, this is bigger. Delta of circumference difference equals C2, this one, this is C2, minus C1 equals C2, 2 pi, instead of radius I can write here R2, step by step, minus 2 pi R1, or 2 pi, instead of R2 I use x plus 6, minus 2 pi x equals distributive property 2 pi x plus 2 pi times 6 and minus 2 pi x. Combine like terms, cancel, cancel. 6 times 2 pi, it would be 12 pi. So new circumference, the name in math in terms of pi, would be longer by 12 pi. Who understands this 100%? Actually, one line problem. I use all the formulas. See? Okay, good, good, good. Ready for more fun, students? So I'll tell a story, very short. Okay, great American actors. Maybe Karen know names. If you know, tell us. So one already in prison, right? Some famous criminal. And second just put in this jail. And the first one has huge turkey. And the second hungry, he did not eat few days. But he loved geometry. He definitely loved geometry. Let me apply how to use this geometry idea to get some turkey. What do you think? And he used exactly what we did today, exactly the same approach. He recalled for what he studied in Dr. Farber's center. All right, let's see. Yeah. Yes. Can you see screen? Yes.
Tastes good. Ain't that the live turkey with all the fixings? Chestnut dressing. Nice hot sweet potatoes. Say, amigo. Which side do you reckon is longer? This one here or this one? Oh, God, I was stupid. So which side's the long side? This here or up the side? You must be crazy, mister. The side's longer. I'll wager that fat turkey of yours. You're on. Now, first we'll measure it this way. And then, you lose. I lose, huh? Even if I won, what would I get? Your turkey. Goddamn turkey was my turkey anyway. It was.
Did you enjoy this fragment, students? Who like this example? Who like this fragment of this movie about pie? Only a few students? So knowledge help you always get some food, always. Maybe not only food. Okay, put your hands down, continue. Very impressive. I love this example. Karen, do you remember the name of these people? If you remember, tell us. We'll check. Oh, some of you muted for some reason. System sometimes muted by itself. Проверь, Karen. Okay.
Okay, now, no, I don't remember those people.
I see.
I am too young.
No, I'm talking about movies, you know.
Yeah, I know.
Okay, Karen, do you like this example?
I do. I love it. It was funny. I'm cracking up.
I hope through homework you get now for 100% of this. Okay, continue. Good students. Never forget. Any questions about this number 5? Sihan, you have questions? You're raising hand. You have microphone. Sihan. No questions? Good. Number 6. Number 6, very fast. Number 6. Pretend we have a wheel. This, what is it? Radius of a wheel is blank. Find the number of feet covered by the wheel in blank revolutions. Okay, let me give some numbers here. For instance, this is 20 inches. Okay. And this is 60 revolutions. This is all for myself, because we're out of time. Then this is the wheel. And it's moving this way. And now the radius this radius equals to 20. Let me make bigger here. The radius equals to 20 inches. And it's moving in 60 revolutions. It will be from here, from A, somewhere to point B. Okay, good. And they ask you number of feet. Like we did before, first of all, convert inches to feet. It would be, 1 foot is 12 inches, right? It would be 20 over 12 feet. Or I can simplify by 2, it would be, or by 4. By 4. I have 5 over 3 feet. So this is my radius. Converting this, but this is my goal. Now, in step number 1. Step number 2. Circumference equals 2 pi r. 2 pi, radius equals to 5 over 3. And you get 10 pi over 3. Unit of, since this is feet, this is feet. But what is it? It's for 1 revolution circumference. Since you have 60 revolutions, this distance, AB, or distance, equals 10 pi over 3 multiplied by 60. 3 goes into 60 20 times. And you get 200 pi. In terms of pi. Keep in mind, student, very often we see answer in terms of pi, the same like on the test. If they ask you to find exact answer, this is exact answer, with 200 pi. If they ask you on the test find approximation, what you're supposed to do, this exact. And this you're supposed to do 200 times 3.14. Why? Because this is irrational number, never ending. I just truncated to two digits of this. When you multiply, you get number. This approximation. To understand this, top typical question for evolutions. If you have a question, ask me. The same when you travel with your parents in the car or the train, keep in mind that you have a wheel, it rotates, more evolutions, bigger distance you cover. Okay, the next question, number 7. Number 7. So what I did, I made imitation of your homework. Just use similar problem with the same problem with different numbers. And you solve this by yourself based on this explanation. Okay, number 5.